Now in this video, we are going to go through Chapter 7, Part 2. You've already watched the earlier video on types and properties of special quadrilaterals, which are four-sided figures. So you need to know all these properties. You also need to know the names of these quadrilaterals. So in this video, we'll go through 3 examples, and you will do the last one by yourself. So in practice 1, we've got a diagram over here. AB is parallel to DC, AD is parallel to BC. So here we have a parallelogram. There are a few angles given to us. Stating your reasons clearly, find the values of x. Now, this being a parallelogram tells us that we've got 2 pairs of parallel lines. Okay, so in particular, I'm interested in this shape. So I like to write down this, which actually helps me remember the different properties for angles. Okay, so for the first one, this, when I see the shape of the letter F, I know that these 2 angles, let's call them A and B. Angle A equals to angle B. So this will be corresponding angles, parallel lines. Okay, so if I have this particular shape, A and B, I'll say that A plus B is 180 degrees. The reason over here will be interior angles, parallel lines. Finally, the last one, A and B. Here we have angle A equals to B. Well, we call this alternate angles, parallel lines. So in this highlighted portion, I see interior angles in this shape. So I know that x plus 36 plus 73 must be 180 degrees. So that's what I'm going to be writing now for part A. X plus 36 plus 73 degrees, 180 degrees. So state the reason, interior angles, parallel lines. So from here we get x is, or rather we write it in the same form, angle x is equal to, do a subtraction, 71 degrees. In part B, after we have found angle x, we are ready to find angle y, but it is not so straightforward. We will be able to do it if we can, for example, find this particular angle. Okay, using interior angles again, because now I've got 36 degrees plus 71 degrees plus this unknown plus 27. It should give us 180 degrees. So from there, we will be able to get this unknown angle, and by considering these 2 angles, I can find y using angle sum of triangle. But I want to show you another technique. We are now going to include our own parallel line. Okay, over here. Since I've got A, B, C, D, and E, let me call this point F. So this line over here is parallel to AB as well as DC. So from here, I can see that there's a letter Z, which means that this particular angle must be 36 degrees. And if I do the same thing again, I can find another letter Z. And now this tells me by alternate angles again, this must be 27 degrees. So quite clearly, we know that y will be equal to 27 plus 36, which mentally gives us 63 degrees. But presentation wise, how are we going to do this? Okay, so let's remove all this first, keeping only our new dotted line. For part B, we are going to state the angles that are the same first. So angle FEA is equal to angle EAB, which is 36 degrees. State the reason: alternate angles, parallel lines. So you got one part of it. The next one, angle FED is equal to angle EDC, which is 27 degrees. Again, alternate angles, parallel lines. So now our final one, angle Y, is equal to angle FEA, is made of these two, FEA plus angle FED, which is 36 plus 27, resulting in 73 degrees. Sorry, 63 degrees. Next question. We've got BC is a straight line and ABCD is a rhombus. So quick recap: rhombus, so all these sides, they are parallel. Opposites angles are the same. The diagonals, they are perpendicular to each other. Okay, so now let's us find angle X. Since opposite angles are equal, this must also be X. If we know that this is X, then X must be 180 minus 68. Okay, so let us present all those properly. Angle BCD is 180 degrees minus angle DCE, which is 180 minus 68 degrees. And this gives us 112 degrees. So we've got the correct answer, but presentation wise is incomplete. So we need to say why BCD is 180 minus DCE. They are adjacent angles on a straight line. Okay, so BCD is 112. Now we can find that angle X is equal to angle BCD. Reason: opposite angles of rhombus. And this is 112 degrees. X is done. Now I want to find Y. We see that in this triangle ABD, we've got two sides, same length. So this is an isosceles triangle, which means that this angle here must also be Y. And when we use this property, we need to state the reason: base angles of isosceles triangle. Okay? So in part B, angle ABD is equal to Y. And we say that here base angles of isosceles triangles. Next, we also say that X plus 2Y must be 180 degrees. This is angle sum of triangle. Earlier on we found X. So X is 112 degrees plus 2Y is 180 degrees. 2Y must therefore be equal to 180 minus 112, 68 degrees, and Y must be 34 degrees. So practice 2 done. And this is the final practice that I'll be going through. Here we have AHD is a straight line. BC is equal to CD. Okay, since these two sides are equal, I know straight away that, hey, I've got an isosceles triangle. If this is an isosceles triangle, I can find both of these angles since I have the third angle. What else did they say? BH is parallel to CD. BH, okay, over here, and CD. These are parallel. Straight away I can see the letter F. I also can see interior angles. I also can see the letter Z for alternate angles. And finally H is a point on AD. Okay, they also give us 3 other angles, stating all reasons. That means you state all the properties. Find BAD. Okay, let's start with the first one. BAD. This is the angle they want us to find. In order to do that, we are going to find angle CBD first. CBD, this particular angle, because like I said, this is one of the first angles that we can first find. Okay, so we need to have a plan. First, let's start again. I need to find this angle. I know that I can get this angle based on 110, and it will be the same angle over here. Once I have this particular angle, I can take 73 minus that to find this angle. In addition, since I have this angle already, I take 125 minus away this angle, which means that I can now have this angle. So given that we found these 2 angles, we can now find the last angle. Okay, so that is our plan. If you have any other approaches which are more straightforward, feel free to share with the class. So let's begin for part A. Angle CBD is the same as angle CDB adjacent. No, these are base angles of isosceles triangles. Okay, so here we can calculate it. It will be 180 degrees minus our 110 degrees divided by 2. So here we are using the property angle sum of triangle. This results in 35 degrees. Okay, so this is 35. This is also 35. So now I will be trying to find this particular angle. So here we have angle BDH. BDA, which is the same as BDH, is 73 minus 35, resulting in 38 degrees. Okay, lack of space, let's move on to this side. This is now 38 degrees. Now I want to find this angle also. So angle ABD is 125 degrees minus 35. We get 90 degrees. Okay, so this is 90. With these 2 angles, I am now able to find angle BAD. It must be 180 minus angle ABD minus away the other angle BDA. Angle sum of triangle. 180 minus 90 minus 38, resulting in 52 degrees. And now for part B, to find angle BDH. BDH, oh, we've already found it. Angle BDH is actually angle BDA. This is 38 degrees. What is the reason? Well, this is found in part A. Now with the remaining time, please do practice 4. You may also begin work on your homework exercise. So this set of notes as well as this homework exercise, they are both due on, let me check, on the same day, which is 30th April, 10 p.m.